Hello Henry, hello being an IITian, welcome aboard to the JEE English channel. This is your Captain Shreyas here, your physics master teacher, and today's session is all about modern physics. It includes the chapter of atoms, which also includes photoelectric effect, the properties of photons of course, and the wave particle duality. And then obviously you have the nuclear physics and radioactivity, and then also the questions on semiconductors, electronic devices as well as logic gates. So I have done the short sessions, the quick revision sessions in the fast track series. I'll just show you where you can find it in case you haven't seen that. So that's my name, that's your physics master teacher, your captain, your navigator, your guide on this channel. My name is Shreyas. You can follow me on Instagram to be my friend and to know more about me. Okay, so I thank you for liking and also recommending this channel to your friends, and thank you for subscribing as well. So if you have missed the previous lecture, I'll tell you where you can find it, guys. Welcome Natarajan, hello Arvind, hello Nandini, nice to see you guys. So as you're on the channel, just you can see there are so many tabs. Just go to the videos tab. You can see I have conducted these lectures. These are quick revision classes, recorded class. This is a live class, this is a recorded class, but this is for formulas, for mind maps. And you would have understood why I'm recording it, because it takes a lot of pain, a lot of effort to record this. I don't know how many of you realize that it is actually difficult to make a recorded class than a live class, because I have to think what I should say, what I should keep in those lectures so that things are very crisp and very clear and you understand it and you can revise it. So, you know, entire logic gates, semiconductors in 35 minutes. I mean, come on guys, nuclear physics in just 20 minutes. Then I also did atoms, dual nature, photons, photoelectric effect in just barely 30 minutes. So in barely 1.5 hours, you have revised the entire modern physics. Can you believe that? Entire modern physics in just 1.5 hours. So that's the beauty of the fast track series. Okay. Vanakkam Vishwajit, nice to see you guys out here. I'll just probably put up your chats on the screen so that you can see yourself and probably you can see others too. Hello Janani, okay fine, you are in some different account I guess. Hello Nandini, nice to see you. Hello Ramu, hello Yukta, Abhiram, Binu. Sir, is there any change in the JEE Mains exam date? As of now, nothing. Yes, there is nothing. Okay, so all excited already? Promise yourself you're staying till the end and participating in each and every question. There is a mixture of PYQs as well as NT-Abhyas as well as my top problems. So it's a mix of all the questions. So let's begin with the class, guys, with full energy, full josh. I hope you smash the like button out there. Okay, here comes the first question up on your screen, and let's see what it is. My mic has some problem, is it, Harish? Okay, meanwhile, start solving this, guys. I hope it is fine now. I hope it is fine. Just check this out. Yep, just try to solve this problem. Meanwhile, I'll just check the settings of the mic in case everything is fine. Okay, okay, great. Chalo, what is the ratio of the circumference of the first Bohr orbit for the electron in hydrogen atom to the de Broglie wavelength of the electrons having the same speed as that of the electron in the first Bohr orbit of the hydrogen atom? Now this question can be solved in many ways, but let me tell you the easiest way. See, one way is using the radius formula. Okay, one method is using the radius formula, which is some r0, and then you have n square by z, and then also using the formula of de Broglie wavelength, which is h by, you know, your momentum, which is mass into velocity, and then again relating velocity and radius and all such things like mvr is equal to nh by 2 pi. So all these equations you might need using method 1, which is a painful process, lengthy process. Instead, I would suggest an easier method, and many of you might have realized it. That's why you have put up the answer really quick, and that's what matters in JEE Mains. So whenever you have any electron in any orbit of a hydrogen-like atom, or basically which follows Bohr's model, it so happens that the de Broglie wavelength exactly fits into the entire circumference, meaning the circumference is basically an integral multiple of the de Broglie wavelength. Understood? So the entire circumference will be 2 times, 3 times, 4 times, 1 time, 10 times, 100 times, basically n times of the wavelength. Exactly integral number of wavelengths are going to fit in. So from this, my warriors, C bar lambda, isn't it going to be n? C bar lambda, isn't it going to be n? Yes. And look at the ratio which has been asked. The question says, what is the ratio of the circumference? You can see circumference over here, and with the basically the de Broglie wavelength, to the de Broglie wavelength. Circumference by de Broglie wavelength. Exactly, that's what has been asked. For which orbit? For the first Bohr orbit. For the first Bohr orbit, what is the value of n, my dear students? N is 1, right? So C by lambda is 1:1. That is the answer. Hello Janana. I am much better, Priya, but today my head is aching like anything. So I just had a cup of tea. I hope I am fine by the end of the class. But yeah, thank you for asking. It shows that you guys really care about the teachers over here, just like we do about the students. It feels really awesome. Those small few words which you ask to us in those live sessions, it means a lot. Thank you so much, guys. Thank you so much for your concern. It means a lot. Okay, so let's move on to the next question coming up on your screen, and here it is. Okay, so the energy that should be added to an electron to reduce the de Broglie wavelength from this to this will be how much? From this to this will be how much? What is the formula? C is equal to n lambda. Harish, like I told you, it is basically this circumference. The circumference will have basically some integer times the de Broglie wavelength. That is what the formula is. It's a standard Bohr's principle, or I can say it's the outcome of the Bohr's model of an atom. Okay, this is a standard result in atoms, and it comes from this. It basically comes from this postulate, MVR is equal to NH by 2 pi. If you just move this around now, you're exactly going to get this. Is that okay, bacha? Everyone? Hello JEE 2024, nice to see you, bacha. Vishwajit saying for this question, option is A. I don't know, let's figure this out. You can see from here to here what has happened. The de Broglie wavelength has become half, right? De Broglie wavelength, if it was lambda, it has become 0.5 times of it. That means it has become halved. So wavelength has become half times. Now how is the de Broglie wavelength and energy related? If you think about it, the de Broglie wavelength is h by the momentum, and the momentum is nothing but root of 2 times mass times, you know, the kinetic energy of the particle. That's right. Okay. Now if the de Broglie wavelength becomes half, so that means lambda will become lambda by 2. So this will become h by root of 2m new kinetic energy. So from this, if you compare, all you need to do is just take the ratio, my dear students. If you just take the ratio of these two things, if you divide this with this, so this will become 1, or rather lambda by 2 will be equal to h cancels, root 2 cancels, mm also cancels. So I will have root k over here, and I will have root k1 on the top. Lambda also cancels, 2 goes on the top. So 2 will be equal to root of k1 by root of k. So shift it over here. So 2 times of root k will be root of k1. So from this I will get k1 will be equal to, square both sides, it will just become 4 times of k, right? It will become 4 times of k. Immediately you will think 4 times the initial energy. That's what you might think the answer is, but be careful. The question says how much energy should be added. How much energy should be added? Original energy was k. This was the old energy. The new energy is basically 4 times of k. So how much are you adding? 3k, right? K plus 3k is 4k. So the correct answer is thrice the initial energy. This is how J is going to trick you. Everybody with me? Within 2 weeks, maths and physics can be completed completely for us. Sanjit Krishna, am I joking or you are joking, bacha? How can you complete entire maths and physics in just 2 weeks? If somebody has told you that they can complete entire maths and physics, please watch those channels. 100% you will succeed. Okay? If you want to really complete entire maths and physics in 2 weeks, it's humanly impossible, bacha. Okay? Yes, Vishwajit, fallen into the trap. So be very, very careful. When it says energy that should be added, that means it is that extra energy. So all these are things that you learn through these problem solving sessions. So please make sure you are attending it, and make sure you have smashed the like button, and also subscribe to the channel so that you do not miss the future classes. Okay, what is the next question? The binding energy of the atoms A and B are this and this. 3 atoms of B combine together to give A. the fusion process is accompanied by release of energy. If E and EB are the binding energies, so question is what is the relation between them? What is the relation between them? Okay, so Henry Joseph, welcome bacha. Let's try to solve the question now. Let's try to analyze the reaction. Okay, try to think what is the reaction. Element A and B are related to each other. How are they related? 3 atoms of B fuse to give 1 element of A. 3 atoms of B fuse together to give 1 atom of A. Now in order to find how much energy is released, which is also called as the Q value of the reaction, remember there is a formula for the Q value. It is nothing but the binding energy of the product minus binding energy of the reactant. This is the standard formula. In this case, the Q value of that reaction is given to be E. As per the given statement, the fusion process is accompanied by energy release of E, which is also called as the Q value of the reaction, which is the energy release, simply put. Binding energy of the product means binding energy of A. Binding energy of the reactant means it is energy of B. Okay, but there are 3 atoms, so put 3 times. So this is the equation. See which of the options will match. I think C option might match, because if you shift this guy over there, it will become E plus 3 times of EB is equal to EA. Now 3 times of EB will become EA minus E. That's it. So I think it is option number C. Yes, it is. You can see that. Very nice. So it is not D, it is not B. Be very careful. Many people forget that whether it was product minus reactant or reactant minus product. So I understand it is always product minus reactant. Final minus initial. What is the outcome minus what is the incoming thing. Is that clear? Okay. Okay. Very good. Very good. Very good. Sir, no sir in fast track series. What is no sir in fast track series? Sanjeet, what do you mean by that? Okay. Let's begin with the next question, guys. Sir, when will the class begin for JEE 2024? Navdarshan Thalyan, let me tell you, bacha, if you are following the fast track series, whichever 11th standard topics are there, you can use that, number 1. Number 2, nurture series is already there. So if you are subscribe to the channel, you can go to the playlist. You can find all my lectures right from units and dimensions till the last class. You can also find one shots in the 0 to hero. You can also find problem solving sessions. Everything for 11th standard is already there. But yeah, live classes will obviously start after some time, not now. Okay, let's begin with the next question. A proton with kinetic energy K describes a circle of radius R in a uniform magnetic field. An alpha particle with kinetic energy K moving in the same magnetic field will describe a circle of radius how much, guys? Come on. Navdarshan, live classes? Yes, definitely. Definitely live classes will start, but not now. It is only for 2023 now, but 2024 students, please understand that your seniors need your help. I hope you understand that. Okay, so proton with some kinetic energy goes in a circular path. So why is it going in a circular path? Because of the magnetic force. We all know that when you put a charged particle in a magnetic field, something like this, then the radius of such a thing is mv divided by qb. That is how it works. But here kinetic energy is given, all right, charge will be different, mass will also be different. So I feel that maybe instead of mv, what I can write it as momentum by qb, and momentum is root of 2 times of mk divided by qb. Now you can see that the radius is directly proportional to the root of mass. Kinetic energy is the same kinetic energy is there here and here. So kinetic energy, just forget it. Charge is going to be different because this is proton, this is alpha. Magnetic field is also the same. So it is inversely proportional to Q. So from this what I get is R2 by R1 will be, because it is proportional to root m, so this will be root of m2 by root of m1. And inversely proportional to charge, so this will be q1 by q2. Now in the second case, because it is alpha particle, I don't know what the new radius is, but the old radius is given to be r. Okay, the mass for alpha particle is obviously 4 times more than the proton. If it is m for a proton, for alpha particle, because 2 protons, 2 neutrons, so it will be 4m. Everybody gets this? Everybody gets this? So Naresh, Srinu, Shimon sir will be back. Maybe you should ask Shimon sir, bacha. I'm not sure. Just ask Shimon sir. I don't have the answer for that. Okay, Q1 by Q2. What is the answer for this, guys? Check this out. Charge 1, proton's charge is going to be E. The alpha particle will have a charge of 2E, right? So this will be nothing but 2E. Okay, so mm cancels, root of 4 is 2. This will become 1 by 2. So basically this will become 1:1. So R2 by R is 1:1. That means R2, the new radius, is just simply put R only. Exactly. So where is it? Option B, right? There you go. Option B is correct. Awesomeness. Awesomeness. What are the chapters included in modern physics? It includes all the things: atoms, photoelectric effect, photons, wave particle duality, nucleus, radioactivity, semiconductors, electronic devices, logic gates. All these are part of modern physics. Okay? Yep. So Sanjit, like I have told before also, for fast track series, my first priority for you guys is high weightage topics, not sequential topics, high weightage topics. If time permits, then medium weightage. If time permits, then low weightage. So that will be the order of fast track series. And if you want to know which are the high weightage topics, just watch the video which I just made few days back. In case you have not seen that already, please make sure that you check it out, because it is going to be the most important session for all of you. In the videos part, you will see high weightage JEE physics topics. Okay, already got 9.4K views. Just check it out. It's very important session. All the important topics I have mentioned it for you. Next question up on your screen. A photosensitive metallic surface has work function hv0. If photons of energy this much fall on this surface, the electron comes out with maximum speed of this much. That's the measure of maximum kinetic energy. When the energy of the photon is 5 hv0, then what is the maximum speed? Okay, I think we will use the photoelectric equation to solve this question. What is the photoelectric equation? It is basically HF, the energy of the photon, is nothing but equal to work function plus nothing but, you can say, okay, it has work function over here. So instead of work function phi, I can just put it as HF0 plus the kinetic energy, right? That's the standard equation. So in the first scenario, the photon has an energy of 2h0. So 2h0 is equal to work function is h0 plus the kinetic energy. Okay, I don't know what's the kinetic energy. In the second case, what is the energy of the photon? It is 5 times h0. Work function won't change, so h0 plus the new kinetic energy. So what can we do from here? I know what we can do. In the first equation, okay, Harish, don't question why not this. See, if I do current electricity, some student will ask, sir, why not that? So there is no point in asking such a question, sir, why are you not doing that? Why are you not doing this? I have to follow some order, right? If I do this, you will ask why you are not doing that. So focus on what is being done, not on what is not happening, or sir, why not that? Why not this, etc. So here you can see kinetic energy will be 2h0 minus h0, which is just going to be h0. Okay, interesting. Over here, if I shift this h0 term over here, I will get 4h0 is equal to k1, but h0 is k, so therefore I'll get 4 times k is k1, but I also know kinetic energy is half mv square, so I can just write 4 times of half m, the v square originally is equal to half times m times the new speed square. Half m cancels, so 4v square is basically v1 square, so therefore v1 will be taking roots on both sides, it will become 2 times of v, root of 4 is 2, so the new speed is twice the speed, that means the new speed will be 2 times of, what is the old speed? It is 4 into 10 to the power 6, so that's why the correct answer will be 8 into 10 to the power 6 meters per second, and that is nothing but option number D. Check this out. Everybody, yep, it is option D, Arvind, be careful. How many questions you can get from modern physics? Anywhere between 2 to 4 questions. 2 to minimum, that's what has been found regularly. 3 is most likely. 4 is also possible. Okay, 4 is also possible. All right, everyone with me on this? I'm so glad, Pravalika, my Zero to Hero series was very helpful for all of you. Thank you so much. Thank you so much for loving it. Moving on to the next question coming up on your screen. Are you guys enjoying the session? Hello Akash. Everyone ready for the next question? Come on, try to solve this. A freshly prepared radioactive source, half-life 2 hours, emits a radiation of intensity which is 64 times the permissible safe level. The minimum time after which it would be possible to work safely with this source is, come on, think about it. The current permissible level is 64 times higher. So the radioactivity, okay, the radioactivity has to decrease 64 times, only then it is safe. How long do you think you will have to wait? Thank you Lokhan, thank you so much for being my fan, thank you so much. Thank you Sunny, thank you so much. Means a lot. So here is what I'm going to look at. If my activity has to reduce by 64 times, that means how many half-lives I have to undergo. How many half-lives I have to undergo? Every half-life the activity becomes half. Next half-life it will become half of the previous one, and so on and so forth. So it will happen basically n number of times. Basically I can say 1 by 2 the whole raised to n is basically, it becomes 1 by 64 times. It has to become 1/64th of the original activity. Only then I can say that it is safe. Whatever the activity was, it has become 64 times less, or it has become 1/64th of the original activity. So this is 1 by 64. So guys, 2 raised to n is 64. So n is how much, guys? Isn't it 6? Isn't it 6? So 6 half-lives. So guys, 1 half-life is 2 hours. So the total time will be n multiplied by the half-life. The number of half-lives is 6. Each half-life is 2 hours. So total answer will be 12 hours. Where is 12 hours? It is option B. Very good. That is the correct answer. How many of you got it? Very good, Harish. Very good. Yes, so many of you got it. So many of you got it. Thank you, Hari, so much. Thank you, KB Bharat. Vikram, nice to see you on this channel too. Sir, a small doubt. How much time do you think is enough to complete the physics paper, as maths paper is so lengthy? And what others prefer, sir? Which subject to be chosen first? Okay, I'll answer. Meanwhile, I'll just post up the next question for all of you who want to start solving. So, Akash, if maths is your tough part, then I would say if chemistry is something which you can easily do, start off with chemistry, gain some confidence. Okay, try to complete chemistry in 35 minutes to 40 minutes. Max, push it till 45, but not more than 45. 40 is ideal. And then you can move to physics. Take 1 hour 10 minutes to 1 hour 5 minutes, around somewhere around that. And then the remaining time you can use it for maths, because in that first 2 hours you would have easily conquered, I would say, as many marks as you can from the 2 subjects. So you are little bit tension free. So then how much ever you can do in maths, try to do it, and maybe you can solve 10 questions or 12 questions or 15 questions. That is a good enough number if you are aiming for any decent scores. Okay, that's what I would do if I was in your place. Okay, the number density of electrons and holes in a pure germanium at room temperature are equal, and its value is 3 × 10⁻16. On doping it with aluminium, oh guys, aluminium, it's basically trivalent. It is trivalent impurity. So the moment it is trivalent, it will create holes. It will create holes. Basically, it is a P type of semiconductor. It is a P type of semiconductor. The question is, what is the electron density in that particular semiconductor device? KP Bharat, can you just rewind back a little bit and watch it again, bacha? It is very, very simple. Okay, it's just basically you just have to think how many number of half-lives are involved, because the activity reduces 64 times. So 64 is 2 raised to what? 2 raised to 6 is 64. That's how you are going to solve the problem. That's all. Just think, because activity has to reduce to be safe. So 64 is which power of 2? Because every half-life the activity reduces by half. That's the logic behind it. Now, coming back to this question, we know the standard formula NH into Ne is basically intrinsic concentration whole square. Standard formula for any semiconductor's concentration. The whole concentration the whole concentration is basically 4.5 into 10 to the power 22. Electron concentration, I do not know. Intrinsic concentration, because when the number density of electrons and holes are equal, that is pure semiconductor, that is for intrinsic semiconductor, what is the concentration? 3 into 10 to the power 16 whole square, correct? So when you square this, this will become 9 into 10 to the power 32. So Ne will become, take this below, so this will become 4.5 into 10 to the power 22. 9 by 4.5 is 2. This will become 10 to the power 10. So the number of electrons per unit volume, the concentration of electrons, will be 2 into 10 to the power 10 per meter cube. Very good. Everyone with me? Yes. Whole concentration. Yes. Glad KP Bharat you understood it. Hurry. Don't wish, bacha. You already have a teacher like me over here. Don't have any regrets. You are getting the best of the best knowledge over here. During our times and just few years back, there was no YouTube lectures, and I'm so glad that this online revolution has happened, and every student, no matter which town, city, whether he's privileged, not privileged, rich, poor, doesn't matter, this board, that board, you can always have access to the best content. And my aim over here on the JEE English channel is to ensure that all the English speaking students or all the students who want to learn in English, no matter which medium you are studying in, always get the best of the best content at par or even better than all the other Hindi channels or other language channels, right? So that is my aim over here when I come and teach you guys. So let's move ahead to the next question coming up on your screen. In a photoelectric experiment, the wavelength of the incident radiation is reduced from 6000 to 4000. Then the stopping potential will increase or decrease, or kinetic energy will decrease, or what is it? The value of the work function will decrease. Brilliant question, guys. Bhargav, if you are starting the JEE Mains preparation from now, if you are already in intense preparation and I am getting 90 plus marks in mock test, so Bhargav, you will be clearing mains, but clearing mains is not the end game. You have to get into at least NIT. So for getting into NIT, at least 150, 160 marks is something which you will need. So you have to boost your preparation by at least 50 marks. So yes, boosting your preparation by 50 marks is possible. But if you are starting from scratch, the answer would be no. But since you said that you are already in the, intense preparation, so I'm pretty sure in the last few weeks you can do some things. Okay, let's move on. Option B, is it? Very nice. Proud of you, Nitesh, Saran, Arvind, who and all. Very nice. Ramu said C. No, it is not C, bacha. It is option B. How do we do this? You can see that the wavelength has reduced, and this equation hc by lambda is work function plus kinetic energy. So if the wavelength reduces, this term will increase. LHS increases, so RHS should also increase. So that's why you will see kinetic energy increases, and the moment kinetic energy increases, which is E times of Vs, you will see the stopping potential also increases. So hence the answer is B. Work function depends on the material. So work function will not change just because you change the light. It's a property, characteristic of the material or the metal. So that will not be affected. Alright. So I hope this is clear. Moving on to another question coming up on this. Alright. So guys, here it comes. When a certain metallic surface is illuminated with monochromatic light of wavelength lambda, the stopping potential of photoelectric current is 3 V naught. When the same surface is illuminated with the light of wavelength 2 lambda, then the stopping potential is V naught. The threshold wavelength for the surface for photoelectric effect is, come on my warriors. Come on guys, Akash, everyone focus on the lecture. Any specific doubt, probably you can keep it till the end of the class. I'll try to answer it. Right now I want your entire focus on the problem solving. When this surface is, incident with or illuminated with wavelength this much, stopping potential is this much, wavelength changes, stopping potential is this much, threshold wavelength. Okay, that means I need work function and all of that. So here is what I think. Initially hc by lambda will be phi plus the stopping potential is 3 V naught. So plus E times of Vs is 3 V naught. I hope you remember what is this equation coming, or where is this equation coming from? It is basically hc by lambda is work function plus EVS. This is your standard equation. From this I am getting this. Okay. The next part of the problem will be for the second situation. When wavelength is this much, stopping potential is this much. So hc by 2 lambda is basically same work function plus E times of V naught. Now the question is, what is the threshold wavelength? Threshold wavelength means I need phi, and every answer has lambda, it does not have V naught. So I will try to eliminate V naught. How? By probably subtracting, but even before subtraction, let me multiply this with 3 so that when I subtract them, both these terms get cancelled. So just multiply this equation with 3, it will become 3hc by 2 lambda is equal to 3 phi plus 3 E V naught. Now the next step will be just subtracting the two. So basically this is equation 1, this is equation 2. So just imagine if I subtract 2 minus 1, this equation minus this equation. So what am I going to get, guys? 3 by 2 minus 1 times of hc by lambda is equal to 3 phi minus phi. 3 EV naught cancels, guys. Do you see that? 3 EV naught and 3 EV naught just cancels. Don't worry about it. So what's the next step? 3 by 2 minus 1, half will be remaining. So this will become half hc by lambda is equal to 2 times of phi. Okay. I don't want phi, I want the threshold wavelength. So my next step will be half hc by lambda is equal to, okay, this 2. Phi, which is the work function, is also given by the formula hc by lambda naught. This is basically your threshold. This is basically your threshold wavelength. Everybody remembers this formula. The work function is hc by lambda naught or hf naught, threshold frequency or threshold wavelength. hc cancels, so I'm just left with 1 by 2 lambda is equal to 2 by lambda naught. So take lambda naught on the top, it will become 2 times of 2 lambda, which is basically 4 times of lambda. So that is the final answer. Everybody understood? Great. So look at this, option B is correct too, and many of you got it. Very good, Nitesh, and so many of you have got the correct answer. Pravalika, please watch my yesterday's class. That was also a motivation to boost up your morale. So yes, obviously before the exam, I will conduct a motivation class definitely for my dear students. But for now, the motivation should be to get marks. The motivation should be the picture which I shared. Please join the Telegram channel. I have shared one beautiful picture. Also, it's there in the community. Okay, so please check that out. And Hemant, if you want to watch current electricity, watch my current electricity 0 to superhero series. That will definitely boost up your preparation in that particular chapter. Do not leave that chapter, very important. And if you want some detailed analysis, my Pathfinder playlist is there. Please watch that. All lectures are there, right from derivations to every single thing, to measuring instruments and all of that. Okay, I think this will be answered by everyone. There is an element which is undergoing alpha decay, then beta decay, then alpha decay, then gamma decay. If the original nucleus had 72 protons, 180 was the mass number, question is, what is the final mass number and atomic number of this element? Everybody should be able to give this. Cricket Hawa saying B, okay. Vaishnavi, I have already given the topics which can help you get 70 plus marks. Check that video, bacha. See, that's what I feel bad. I have made such videos for you where you don't even have to complete syllabus and you can score at least 2/3 marks. Please watch that. It's there for you. And those topics are hardly 11 topics to 10 topics. That's it. 10 to 11 chapters can give you more than 2/3 marks. Okay, so what is the answer for this? First of all, original mass number is 180. Then it is 72. Now what happens is in the alpha decay process, this will reduce by 4 and this will reduce by 2. This is for alpha decay. So finally, what will you get after this? You will get this as 176 and this you will get it as 70. This is after the first alpha decay. Then what happens is you have beta decay. So in beta decay process, nothing changes on the mass number side, but atomic number increases by 1. So my dear students, this is just going to become 71 and this will still remain 176. Then again you have alpha decay. So again this will reduce by 4, this will reduce by 2. So 176 minus 4 is 172, and this will reduce to 69. Last step is gamma. In gamma, nothing happens. It just gets de-excited. Nor mass number nor atomic number changes. So this will remain 172, and this will keep it as 69. That's it. Yep, very good. Very good. According to your guessing option series. Oh my god, kya baat hai. Very nice. Oh, so some of you, oh, look at this smart people. You know what KP Bharat said? How many of you watched that series which KP Bharat Vikram has said? Not watched it yet. Not watched it yet. You know, KP Bharat has used a very smart strategy. Do you know what that strategy is? Okay. So guys, those of you have not seen it, let me show that to you. Thank you for reminding. But please don't use these methods every time. Few questions, okay, here and there. Harish has watched it. How many of you watched it? Just raise your hand. Just put up a thumbs up. Just put up a thumbs up, guys. Okay, it's there right over here. Guess options in JEE NEET. Amazing trick by Shreyas Sir. Okay, so if you have not watched it, just check that out. Already almost like 165k views. Wow, nice. Thank you so much for watching it. So it's right over there, and using the techniques which I have shown in that particular video, without even solving, you can get the answer. That's the best part. Okay. Anyways, moving on to the next one coming up on your screen. Yes, you didn't even touch the pen. Very good. Very good. Hello, Vivin. Nice to see you guys. Looks like so many of you watched it. Great. So many of you haven't. Please watch it then. Not now. Later on. First complete the session, okay? Or you're like, sir, I'll watch that session and come back. No, first watch this. In a PN junction diode, not connected to any circuit. Oh, basically not connected means it is unbiased. It is unbiased. There is no forward, there is no reverse. What is the answer for this? What is the answer for this? Come on, my dear students. So when you have a PN junction, this is P, this is N. The electrons from the N jump over to here. Jump over to here, this will become negative charge, this will become positive charge, right? So because of that, there is a potential barrier created, and there is electric field which goes from this side to this side. So this is the electric field. Always electric field goes from high voltage to the low voltage. Yes or no, guys? High voltage to the low voltage. Yes or no, guys? Correct? Awesome. So what is the answer? Joyce Mary, nice to see you back after such a long time. Yes, the correct answer is there is an electric field directed from the N side to the P side. Very good, very good. So many of you got it finally. So potential is not going to be same. Obviously one is high, one is low. Field is going to be there from high to low, and obviously P is at low and N is at high. Okay, so that's how it is. Obviously B option will be wrong because it says P is at high. No, P is at low and N is at high. Moving to the next question, which of the diodes is reverse bias? Paravalika, how to concentrate because I have a mind wandering every time. Number one, cut out all the distractions in every possible way. Number two, keep some motivational thing in front of you. Like I used to keep my target, like whatever, all India rank this much, or IIT Bombay, or this or that. So in front of you, so every time you do something evil, you get distracted, that reminds you. Number three, you can ask your brother, sister, mom, dad, whatever. Like every time you probably doze off or sleep or start dreaming or start playing or start doing something which is distracting, then ask them to just, hit you or slap you. That's it. Enough. Or throw water on you. Best thing. Just throw water on your face. Enough. It's proven that whenever you become nervous or whenever you become, distracted, humans have evolved in such a way that the moment you splash water on your face, right, you immediately, wake up and, come back to your senses and reality, and you probably might get back to whatever you're supposed to do. So try that out. Okay. So the correct answer is B. Very nice. Roshan, KV Bharat, Harish, very nice. Awesomeness. Simran, I'm very good, bacha. Yes, Pawan, no cricket, Hawa. No, that's not the correct answer. Very good, Saran. Excellent, guys. So how do we get that? Notice that reverse bias means always what will happen? This is P, this is N, right? So the P is connected to lower voltage, and N is connected to higher voltage. Then it is said to be reverse bias. That's all you have to check. You can see minus 20 is less than minus 10. This is a low voltage. This is low voltage. This is high voltage. So exactly this is going to be in reverse bias. Everywhere else it is in forward bias. You can see that. This is high voltage. This is ground. Ground means 0 volt. Low voltage. P to high, N to low. Forward bias. High, low. High, low. So forward bias. All these are forward biases. Everyone, shall we go ahead to the next one? Coming up on your screen. For the given circuit of ideal PN junction diode, which of the following statement is correct? Come on, my dear students. Everybody should be able to do this. Hari, come on, bacha. This is English channel. Please converse in English. Hai na? Okay. Let's do this. Come on. Figure this out. What about fill in the blanks without options? Vandana Reddy, what do you mean by that? You mean those kind of questions? Or you want me to do it, or something else? For the given circuit of ideal PN junction diode, which of the following statements is correct? Forward bias, reverse bias. Okay, let's just think about this. First of all, in forward bias, okay, I think it is in forward bias, obviously. So whichever options are reverse bias, most likely I'm not going to look at it. So look over here. The current goes like this, current goes like this, it comes like this, it comes like this. It's an ideal diode. That means what is the voltage drop here? Come on, put it up in the chat box. Across the diode, what is the voltage drop? 0 volt, right? Negligible drop, correct? So whatever this V volts is there, where would it be dropped? Think about Kirchhoff's voltage law. If you travel across this circuit once, here the voltage increases by V, it should drop by V, so that when I return back, I come back to 0 volts. So here the drop of the voltage should be V, right? So drop of the voltage should be V, right? So what is the answer? In the forward biasing, the voltage drop across R is V and across the diode will be 0 volts. Yes, so that means option A is correct. In forward biasing, the voltage across R is V volts. Paneer Salvan, wow, such a fancy, such a yummy name you have. Paneer, nice. Is that your real name, or you have put up some name for display? But you have a very, very yummy name, I should say. In a PNP transistor working as a common base amplifier, the current gain is this much, emitter current is this much, the base current is how much? Let's try to figure this out. Hello Jeevita, good evening bacha log. I hope you guys are enjoying the session, especially all the new subscribers. So here is basically a PNP transistor which is as a common base amplifier. So basically something like this. This is PNP, so the arrow mark is inside, and maybe there is some kind of a voltage here and some kind of a voltage here and so on and so forth. Okay, so this is a PNP transistor, so there will be obviously some kind of a base current, emitter current and collector current. So this is emitter, okay, this is your base and this is your collector. So my dear students, in such a kind of a question, here is what I'm going to do, because the current gain is mentioned and it is less than basically 1. So basically alpha has been given to be 0.96. Alpha is the collector current by the emitter current, that is basically 0.96. So the collector current is basically 0.96 times of emitter current. 0.96 times of emitter current, correct? Okay, now one more thing I know, emitter current is base current plus collector current. Standard result, emitter current is base current plus collector current. So here collector current I just got it as 0.96 times of emitter current. So that is basically your IE. Now bring this IE over here. So it will become 1 minus 0.96 times of emitter current is your base current. Now 1 minus 0.96 is 0.04 and emitter current is 7.2. That is your base current. So therefore the base current is going to be, come on guys, 4 into 72. How much is it going to be? Come on, my dear students. I think it is going to come out to be 0.288 milliamperes. So 0.288 is close enough to 0.29. Yes, option C is correct. 72 into 4 is 288. That's how you get it. Very good. Hello, you Prashant. Nice to see you, bacha log. Nice to see all the new subscribers joining the channel and enjoying the session. Make sure you stay subscribed. Make sure you smash the like button so that you do not miss any of my fast track classes for all of you. This is a problem solving series. There is a similar theory session where I have recorded the sessions in 20 minutes, 30 minutes, 40 minutes, completing the entire high weightage chapters. So starting off with high weightage chapters, you're going to see all the important stuff for your JEE Mains preparation, and obviously the problem solving session is going to continue. Oops, I think by mistake I showed the answer. Oh, there is no question slide only. Oh, okay. Anyways, now that we know the answer, let's just try to reason it out. Is the answer there on the question there on the next slide? No, I think there is a question slide which is missing. It's okay. I'll just try to explain this to you then. 13.6 electron volt is energy required to ionize the hydrogen atom. The energy required to remove the electron from n is equal to 2 is. So this is n is infinity. This is n is equal to 2. This is basically n is equal to 1. So what is given in the question is this. If you take out the electron and bring it over here, you need 13.6 electron volt. Question is how much energy you require to make it go from here to here. So that's basically the question visualization wise. So we all know that the ionization energy from here to here, okay, ionization energy from here to here is 13.6, okay, and you are going to have z square over here, n square over here. So in the first case it was basically 13.6 electron volt, but in the second case ionization energy in the second case will be z is 1 only, n will be 2, so it will be 13.6 divided by basically 2 square, which is 4, which is just going to be 3.4 electron volt. In the first case, understand z was 1, n was also 1. Z was 1, n was also 1, so you will get ionization energy as 13.6, but in the second case it will be 1 by 4 times of the old energy, which is 3.4. Is that okay? Can we see any repetition of question in JEE? Maybe not exactly, but maybe with values changed, and maybe what is given is asked and what is asked is given, or almost same pattern, but values has been changed little bit, few things has been changed, like maybe instead of solid sphere they gave hollow sphere. So stuff like that has happened, and especially in the last few years it has happened more frequently, because there are, imagine guys, 2 attempts, each attempt having 12 shifts to 10 shifts, so it's bound to happen. Okay, how many questions will you get? Okay, I hope this is clear. The wavelength involved in the spectrum of deuterium are slightly different from that of hydrogen spectrum, because how many of you are going to crack this 2003 JEE question? Let's see. Come on, my dear students, figure this out. I want everybody spamming the answer. I'm waiting for every one of you to put up the answers in the comment section. Why is the spectrum of deuterium slightly different than the hydrogen spectrum? In hydrogen, you just have one proton, and then you have this electron which is revolving around it. This is hydrogen. In a deuterium, you have a proton and you have a neutron, and then you have this electron which is revolving around it. So this is hydrogen, and this is nothing but your deuterium. Why is the wavelength or the spectrum slightly different? The answer for that is not because the attraction is different. Guys, a lot of people have made this mistake in 2003. This is not the correct answer. C is correct. How will neutron give a different force here? Think about it. Neutron is chargeless. So how will the force change? Is it a proton? No. So why will the force change? Force is not changing because the mass has changed. You will see the entire, basically the manner in which they revolve will slightly change. And the concept behind this is basically that whenever an electron revolves around a proton, they actually revolve around the common center of mass. And right now, because there is one proton here, one electron here, the center of mass is very close to the proton, and they revolve such that even the proton shakes and the electron also shakes. That effect is usually neglected. When there is a proton and neutron, you will see the center of mass will come even closer. And then the shaky behavior changes a little bit. The electrons, the radius, orbits, etc. also change a little bit. So whenever a body is revolving around another body, actually the other body is also revolving around it, but you generally do not see the motion of the heavier body because it's very heavy. The center of mass is almost on the body. So when you change the mass, center of mass changes, the revolution, orbits, etc. change. So energies change, radius change, wavelengths also will change. That's the reason. So the masses of the nuclei are different. Is that clear, my dear students? Everybody? The size does not matter. What will you do with the size? Does size change the force? No. Does size change the center of mass? No. Even if the size increases, center of mass is still there only. Even if the size increases, center of mass will be center of the sphere. So it will not be affected by the size. Is that okay, Harish? Very good. Awesome. Awesome. Chalo, let's do the next question coming up on your screen. When a uranium nucleus is originally at rest and decays by emitting an alpha particle having a speed u, the recoil velocity of the residual nucleus is? The recoil velocity of the residual. Come on, guys. Again, a previous year question. So you have a uranium nucleus which is basically U-238. It emits an alpha particle. It has a mass number of 4 and it also emits another daughter nucleus. It also emits a daughter nucleus which has a mass number of 234. Obviously mass number has to be conserved. So if this guy moves here with speed u, this guy will move here with speed v. How do I find that? I think I have to use conservation of momentum. So conserve the momentum. Conserve the momentum. You know that this guy was initially at rest. So initial momentum was 0. Final momentum will be, this guy will have mass of 4, velocity of u but negative wise, plus this guy will have mass of you know how much, 234, velocity of v. So moving this across, so 234 times of v will be basically 4 times of u. So basically v will be 4 by 234 times of u. Now many students after looking at this immediately mark this, but be careful. Although this equation looks fine, this is just the magnitude comparison. If you look at it vector wise, the final velocity is negative, opposite direction, right? So 4 by 234 times of this velocity. And since the question says velocity, so that's why you need to put this minus sign, because they are opposite in directions. They are opposite in directions. So where is it? Option B. Yes, it has to be negative. So you have to eliminate option C and option A. So out of these two, it has to be 4 by 234 by conservation of momentum principle. Everyone understood? Oh, clear? Oh? Can we move ahead to the next question? Okay, coming up on your screen. Here it is. Binding energy per deuterium, per nucleon of deuteron and helium is this and this. Two deuteron react. Okay, the two deuteron nuclei react to form a single helium nucleus. Then the energy released is how much? Okay. Vishnu, we are doing all kinds of questions, bacha. Let me tell you the recent year papers questions. All right. Already the solutions are available, which I have done on this channel. Okay. Recently only, last year's paper discussion, previous year's paper discussion, I have done it. But also exclusive PYQ sessions will also come up in the days to come. So right now, I'm trying to give you all models of paper. Even if you see the recent models, they are based on this model. It's not like they are anything different. So even if I change the year number and I give you same question, it's the same thing. So don't worry, sir, why 2004? It has changed, sir. We are 20 years ahead. Don't worry about that. Okay? Cool? Chalo, let's try to do this. If the two deuterium nuclei react to form a single helium nucleus, that means 2H1, but there are 2 atoms of that, gives you 1 helium nucleus. So here is my take on this. In order to find the energy, find the binding energy of the product and subtract it from the binding energy of the reactant. Here the product is helium, so basically binding energy of the helium. But be careful, there are 4 nucleons here. So 4 times for helium, the binding energy is 7. So 4 times of 7. Remember, this is per nucleon. There are 4 nucleons, so 4 into 7. Minus, there are 2 hydrogen atoms. So put 2 over here first. The binding energy of a hydrogen nucleus will be, because each hydrogen has two nucleus, or sorry, each hydrogen has two nucleons. 2 times of 1.1 will give you binding energy of helium. So there are, this 2 is because there are 2 atoms, and this is because there are 2 nucleons. 2 nucleons. This was 1.1 mega electron volt per nucleon. There are 2 nucleons and there are 2 atoms, so that's why this. So this will become 28 minus 4 into 1.1. So 28 minus 4.4, guys. So what is the answer that is going to come out to be? 23.6 mega electron volt. Just check it out. Yep, option A. Yes, it is. I hope this is clear. Okay, great. Awesome, awesome, awesome. Great, very good, very good. Understood, oh, clear, oh. Awesome, awesome. Very good, Vishnu. Awesome. A. Arvind. Yes, let's move on. The half-life period of a radioactive element X is the same as the mean life of another radioactive element Y. If they have same nuclei or same atoms, then who decays faster or slower or whatever? Interesting. Half-life of radioactive element X. So T half of X is equal to the average life of the element Y. What is the formula for the half-life? The formula for the half-life is log of 2, right? So log of 2 upon lambda of that, or the decay constant of that element. So lambda x. ln2 by lambda x is half-life. Average life formula is 1 by lambda, but since we are talking about Y, so I'm just going to put lambda Y over here. Okay, Likita, not sure, bacha, it's been long time maybe. Hello, Samanvita Korode. Yes, Vishnu, yes, 2 ln 2 by lambda. Now just move this around. So you will see lambda x by lambda y. Lambda x by lambda y will be ln2, and ln2 is approximately 0.7 or 0.69, you can say, which is definitely less than 1. So that means lambda x is less than lambda y. Numerator is less than the denominator. Lambda x is less than lambda y. That means x decays slowly. There is slow decay. Lambda y is more. That means this is going to decay faster. So which option is correct? Y will decay faster than x, which is option C for Captain Shreyas, of course. Excellent. Awesomeness. Clear? Can we move ahead? So the value of log 2 is important, because if you think log 2 is more than 1, then gone. Actually, the value is 0.69 or close to the 0.7, so it's fine. Moving on to the next one, coming up on your screen. Here it is. Half-lives of two radioactive elements A and B are 2040. Initially, they have equal number. After 80 minutes, how many decayed number of A and B nuclei will be present? Ratio of them. Okay, let's try to solve this. First, let's do this for A. So for A, okay, it is 20 minutes. Okay, half-life. So this is what is given, half-lives. So basically in 80 minutes, how many half-lives will be there? Think about it. If originally n0 number of nuclei are there, so basically 80 minutes means 4 half-lives. 4 half-lives in 80 minutes, right? 4 half-lives in 80 minutes, right? Very good. So what will be remaining? n0 by 2 raised to 4, which is basically n0 by 16. So the question is, how many decayed nuclei are present? This is what is left. This is what is left. That means basically this is undecayed. This is basically undecayed. So if I ask you how much decayed is present, the answer for that will be n0 minus n0 by 16, which is 15 n0 by 16. This is the amount of decayed sample that is present. Be careful. Everybody clear? Harish, I don't even have to use the formula. I'll use simple logic, because everything is in multiples of the half-lives. 80 minutes is multiple of 20 and 40, so it becomes easier to solve. For radioactive element B, original sample has the same number of nuclei, how many half-lives will be elapsed in 80 minutes? Half-life is 40 minutes for sample B, so obviously it is 2 half-lives in basically 80 minutes. So 2 half-lives, meaning n naught by 2 raised to 2, which is n naught by 4, which is undecayed, which is basically left. So the amount which is decayed will be the original sample minus the one which is undecayed, which is n naught by 4. So it will be 3 n naught by 4. Understood? This is the most common mistake which students made in 2016. Now you take the ratio of this. Now you take the ratio of this. A by B. If you take the ratio, what are you going to get? 15 n naught by 16 divided by 3 n naught by 4. N naught cancels. 15 by 3 will be remaining, and I will be having 16 over here and 4 on the top. So this will become 5 by 4. Where is 5 by 4? 5 by 4 is option C. Yes, that's the correct answer. Else, if you make that silly mistake of dividing this with this, if you divide this with this, what answer will you get? I think either A or B you will get. Okay, so then that will give you negative marks. Is that clear? Shall we move ahead to the next question coming up on your screen? Okay, here it is. Hydrogen atom is excited from its ground state to another state with principal quantum number 4. Number of lines in the emission spectra will be. C for captain. Yes, Tarun. Number of lines in the emission spectra will be. Come on, guys. This is the most easiest question. So if you take it till the 4th shell, this is 4, this is 3, this is 2, this is 1. How many number of spectral lines can you expect? Come on, figure this out. All the possibilities that are possible. All the things. Count it. 1, 2, 3, 4, 5, 6. In fact, it is always going to be NC2, which is n into n minus 1 by 2. So it is here 4C2, which is 4 into 4 minus 1 by 2, which is basically 4 into 3 by 2, which is basically 6. Why is it NC2? Why is it NC2? Because there are n number of lines. In that, you will choose 2 at a time. From here to here, from here to here, from here to here. So 2 at a time. So n choices are there, or rather n things are there. In that, you will choose any 2 of them at a time. So NC2 is the answer. So whether it is 4, 5, 6, you can always solve the question using this simple logic. So answer is 6, guys. Very nice. Okay. How did you study to get admission in NIT? Basically, your life story, Sanjeev, maybe someday. But you can just search. I have already made a video on that. My life at NIT Nagpur. Just search it on YouTube only, on this channel. Shreyas Sir, NIT Nagpur life or something like that. You will definitely find it in the top 3 or 4 results only. Yes, it is always NC2. Yep. Moving on to the next question on your screen, and here it is. Wow. This is 2009 question, brilliant question. The transition from 4 to 3 results in ultraviolet. Infrared will be obtained from 3 to 2, 4 to 2, 5 to 4, 2 to 1. Very nice, very nice. Let's try to solve this. My favorite scientist has to be Tesla. I love Tesla because Tesla is not glorified by many communities, and the inventions and the things which he did at that point of time, was shadowed or overshadowed by people like Edison and so many others. So I have huge respect for Tesla, not just the company. Obviously, the company is also doing great, but the one from Elon Musk. But I have huge respect for Tesla, Nikola Tesla, guys. Okay, so here it comes, guys. This is basically the 5th shell. Then we have the 4th shell. Then we have the 3rd shell. Then we have the 2nd shell, and then we have the 1st shell. As per the given question, 4 to 3 transition. 4 to 3 transition gives me what? Ultraviolet. So ultraviolet has a very high frequency. That means it has very high energy of the photon, of that particular photon of light. Now, when we talk about infrared, where is it? Infrared this has basically low energy. Low energy. It also has low frequency. Low energy, low frequency. Which energy will give you the lower energy than this? See, if you jump from 4 to 2, that is higher jump. 4 to 2 is higher jump. 3 to 2 is also bigger than this. Remember, the gaps keep on increasing in size. Here it is small, bigger, bigger, biggest. This is whatever the size is, from here to here is big, 3 to 2 is big, 5 to 4 is small, 2 to 1 is also big. So I feel that this jump has a small energy, low energy, so low frequency. That's the only possible option. So that's option C for Cap 2 again. Yes, I agree with you, Vishnu. He deserved a Nobel Prize. Okay. No, Harish, it is always NC2. It will not change to NC3. Okay. KV Bharat, yes, you can definitely count and say, I understand you might be a NEET student, but because I'm on the JEE channel, so the maths part comes out in me. I assume that students are very well versed with probability and combinations and permutations. But yeah, otherwise you can just remember the formula from NEET perspective, that's n into n minus 1 by 2. Okay, moving on to another question on diodes in the circuit. This is a previous year question. In the circuit shown, figure out the current in the circuit. Figure out the current in the circuit. Come on, my warriors. Figure out the current in the circuit. What is the current? Look at the way in which the diodes are connected. Assume that these are ideal. Oh, interesting. These are ideal diodes. I have a feeling one of them is in forward, one of them is in reverse bias. So if you look at it this way, this battery will supply the voltage here. This diode will be in reverse bias. The current will only go from here. It will go in this particular branch only. Nothing will go over here. It will just flow in this part. Okay, it will just flow in this part. So this branch is particularly useless because this is in reverse bias. And this particular diode over here, since it's in forward bias, I can say the voltage difference over here, is 0 because it is given to be ideal diode. So there is negligible voltage difference, you can say. So don't worry about this diode also. This is 0 volts difference. So if you look at that circuit which is there across, the current will be the total voltage upon the total resistance. Total voltage is 12. Total resistance is 4 plus 2. Ideal diode will not have resistance, will not have voltage drop. So that's why I'm putting 4 plus 2, guys. So this is 12 by 6, which is nothing but 2 amperes. 2 amperes, where is it? Yep, option B. B for IIT Bombay. How many of you have seen the picture from IIT Bombay from one of our own student, guys? Have you seen that picture? Yes or no? Have you seen that picture? No? What do you guys do, man? Look at the community tab. If you are subscribed to the channel, it should automatically pop up. So guys, this is that picture. Look at these students. These students are from IIT Bombay, and I interviewed Ashutosh yesterday. His All India rank 104 from Vedantu. His percentile is 99.999 percentile. Okay, that's huge. So these are the students. He was sitting in the IIT Bombay hostel. So that's what I told you guys. This should be your motivation. I want you guys to be here. You should be in this hostel room next year. Maybe from IIT Madras, maybe from IIT Delhi, maybe from IIT Kanpur, maybe from IIT Jodhpur, maybe from IIT Hyderabad, whichever IIT it is. But look at these faces, look at the joy in them, and I'm pretty sure you too will be, very motivated looking at these pictures. Just browse through the pictures of IIT Bombay or IIT Madras or any IIT or any top college. You will definitely feel like working towards it. You should never feel down. Yes, very nice. Moving on to the next question coming up on your screen. In the circuit below, A and B represent input, C represents the output. The circuit represents NAND or NOR AND. Wow, let's see. Harshitamu, welcome Bachalo. Good evening. Okay, interesting question. Observe carefully. In order to solve this question, here is what I'm going to do. Assume that I give some voltage like, I don't know, example 5 volts. And let's say I give 5 volts or let's say 0 volts over here. This example 0 volts over here. This is a forward bias. This is a diode. This 5 volts and there is a resistor here. There is ground over here. So high voltage will make sure that this diode becomes forward bias. Okay, hardly any voltage drop over here. So maybe this point will also have almost 5 volts. hardly negligible drop. If this is 5 volts and this is 0 volt, the current from here will get bifurcated into two parts. This the current will probably leak out over here in reverse bias. Some current will come over here and some current will go over there. If this is 5 volts, since this is a wire, negligible voltage drop, so this will be also 5 volts. Everybody with me on this? So this is high, this is low. This is high, this is low. The output is also high. You can see that the output is also high. Everybody seeing that? Okay. Now just look at the same diagram but in a slightly different manner. Okay, look at this. Okay, now what if I give a low input over here, that means this is 0 volt, this is 0 volt, both the diodes are not powered up, so there is no drop. This will be also 0 volt, this will be also 0 volt, here also output will be 0 volt, and this is anyways grounded, so this is also 0 volt, so basically no current is flowing, so low gives you low. Interesting. Now what will happen if both of them are powered up? Basically. If both of them are powered up, this is how it will look like. Okay, just look at this. Imagine this is high voltage, this is also high voltage, this is 5 volts, this is also 5 volts. Both the diodes will be powered up in the forward bias. The current will come like this. It will merge and come over here. If this is 5 volts, negligible drop, so this is also 5 volts, this is also approximately 5 volts. This is 5, this is 5, this is also roughly 5 volts, that means it is high. So both are low, answer is low. Either one of them is high, the answer is high. So which gate it is? It is obviously OR gate, because the truth table for a OR gate looks like this. 0, 0 is 0. Low, high is high. High, low is high. High, high is high. So this is the truth table for a OR gate. So understand what is happening over here, my dear students. I'll explain once more. If this is 5 volts, this is 0 volts, this is high voltage, this is low voltage. This high voltage will power up this diode in forward bias. The current will go here. This point will have roughly 5 volts, hardly negligible drop, and the current will distribute, and the current will go here and some current will go here. This is 5 volts, this should be 5 volts because this is a simple wire. In the wire, every point has same potential. So this will be also 5 volts. So low and high gives you high. If this was low, this was high, still this will be high. But when both are high, you will see both the diodes will be powered up in forward bias. Negligible drop, so both will be at 5 volts. Because both of them accumulate their current, and this is a simple wire, this point should also have 5 volts, which is high. So high and high gives you 1. So that means it is behaving like a OR gate. Understood? Okay. Okay, let's move on to the next question. Is it clear, guys? Oh, by the way, just think and tell me what will happen if these diodes are exactly opposite. If these diodes are exactly opposite, you know what happens? Then what will happen? Then it will not become OR gate, it will become AND gate. Okay, so that's how it works. So if they are forward biased, it is OR. If it is reversely connected, then it will be a basically AND gate. Anyways, moving on. Okay, so here it is. In a full wave rectifier circuit operating from 50 Hz means frequency, the fundamental frequency of the ripple, okay, the output. Okay, let's think. So basically what is it? Full wave rectifier. So in a full wave rectifier, we have the AC signal which comes like this. This is basically your input. This is your input. So you can see this is one wave. This is having 50 Hz frequency. So what will happen? What will happen if I see the output? The output of what kind of rectifier it is, full wave, will be basically like this. You can see this is one cycle, this is one cycle, this is one cycle. You can see the time period has become halved, or frequency has become doubled. So it will be twice of 50 Hz, which is basically 100 Hz. What it means is, in 1 second, if it goes 50 times up and down, here in 1 second it will go 100 times, because here in one oscillation it will do 2 bumps. This is one period, this is one period. So in one cycle there are 2 oscillations of the output, so the frequency is doubled. Hence that is why the ripple which is going to come out, the ripple means like you have ripples of water, so this is also ripples of the signal which is coming out, so that has 100 Hertz frequency. Okay, great. So guys, those are the questions which I had for you. You need to join the JEE English Telegram channel. The link is there in the description box. Make sure you check it out, because the entire PDF will be there, and also the solution and the answer to the homework question. And if you are done with the homework question, make sure you put up the answers in the comment section, so that I know your attendance for this session. And just to remind you quickly, the Ekalavya JEE 2023 aspirants, remember this, the Ekalavya entrance test for all of you is going to be conducted on January 8th and January 12th and January 15th. All these 3 are the entry points. You can give it like a mock test. Even if you are not planning to clear JEE Advanced, think of it like a JEE Mains mock test and give it, okay? And if you are really serious about JEE Advanced, you should definitely consider this, because this is a free batch for JEE Advanced with the top-notch teachers. Although you might say like, sir, I can join after mains first attempt, this Ekalavya batch will also be conducting JEE Mains preparation, like in the form of mock tests, lectures, everything for BitSat, for your EMSAT, everything. So make sure you join the Ekalavya batch as soon as possible. Thank you so much for being here. Rotational dynamics, okay, I'll try, bacha. I think I have planned some 11th standard topics in the next week. I think rotation might be also there. Let's see how it goes. Okay, Akash, in my weekly mock test, if you have 190 plus, but now this complete syllabus test, I'm only getting complete syllabus test. That means it is mainly a problem of strategy, number 1. Number 2, you are not able to spontaneously switch over to one chapter to another chapter. It's just a matter of practice. Give more mock tests, try to switch over. Number 3, try to revise in the night all the chapters, as many chapters as possible, from one concept to other concept. Randomly think, what is the formula for this? Acha, what is the chemical formula for this? Acha, in this periodic table, what is this property? Okay, in maths, okay, this triangles, what are the formulas? Just try to randomly switch over topics. Don't sequentially go, because that is what is important in full syllabus. A lot of students might be scoring well in individual part tests. That means your retention power was good enough for small topics, but when it comes to full syllabus test, you have to switch over, you have to retain, you cannot blank out, you have to strategize, because so many topics are there. You cannot waste a lot of time, you have to immediately move over. So experiment with different strategies, like solve chemistry first, or solve all easy questions first, or solve all hard questions first. So all these things you can try it out. Okay, I hope this is clear. Thank you so much, KP Bharat, thank you so much. And how will JEE 2023 be? Surya Prakash, I am pretty sure it will be rocking for all of you, because you have been attending the classes seriously, and if you have been watching all my lectures, if you have been following all the tips and strategies which I have been giving, I'm 100% sure you will nail it. Okay, and it's going to be easy paper, I feel, because so many shifts are there, and if you look at the trends also, it's very predictable paper. So I feel it will be easy to score 70 to 75 marks. Beyond that, it will be a game of spontaneity, it will be a game of knowledge, it will be a game of your analytical thinking, it will be a game of your speed and accuracy. All these things are going to definitely matter. Okay, all right. Thank you so much. Vijay, if you are bored, you need to basically entertain yourself. You need to motivate yourself. You want to say, I'm bored of preparation. Guys, this is a part and parcel of life. Okay, tell me one joke. I'm not, I mean, if I can tell you one more thing, like if you are getting bored and if you feel that, oh my god, I'm not getting entertained, I'm not having fun studying all of this, trust me, then you will feel that whatever has happened till now is really a joke in your life. Okay, so you don't want your life to be a joke, so make sure that you study well, bacha. Okay, talk to your friends, call up your friends, or maybe watch some small funny video or something like that. I'm not a stand-up comedian, so don't expect me to crack jokes suddenly, and don't pressurize me, guys, like this. Okay, thank you so much. Yeah, okay, so cool, guys. Thank you so much for being here, and have a lovely time. Please watch the fast track mind maps and formula sessions in headphones or in repeat mode. Bye bye. Hasta la vista. Take care. Have your dinner. Take care.